So in all that glitters, we're going to be talking about some different property of matter called density. And we should be able to use the terms and understand mass, volume, as well as density. All these things we've talked about before. We're going to use the density formula to calculate for density, mass, and volume. And I have a nice little graphic organizer trick that'll help us through the rest of the year. So it's important, especially if you guys tend to struggle with using equations, to pay attention to this today. And it will greatly benefit you in the future. Some people call me psychic, but I can predict the future sometimes. And also understand properties that are intensive and extensive. Okay? So we won't be doing too much with this last bullet point, but we should at least have some sort of understanding of those terms. Okay? Are we ready to move on, guys? Okay. So, as we talked about before, all matter has the properties of mass and volume. Okay? So what I want you guys to copy down here is I want you guys to copy down the first 2 bullet points. All right? And I'll pause it here for a sec and explain it. Go. So all matter has mass and volume. Now remember, mass is mass and weight are related. So essentially, mass measures how much matter there is, and volume measures how much space it takes up. These 2 properties both depend on how much matter is present. So, for instance, if I had more air in the balloon, if I kept on blowing air in the balloon, what would happen to the volume of that balloon? It gets bigger. If I keep on adding more gas in there, the balloon gets bigger. It changes. And also, there's more mass of air in there. That's what it means to be extensive. Whoops. Extensive properties depend on how much matter there is. So, like, if I have more of a substance, like if I have more water, Gabby, what happens to the mass of that? If I add more water to something, what happens to the mass of that water? Well, do I have more water, or doesn't it change? Will it be heavier? Yeah. If anyone has ever carried water jugs, the more water that's in there, the heavier it is. That's what it means to be extensive, that type of property. It'll change depending on how much there is. Like if I pour more water in something, it'll have more volume. Won't it? Makes sense. It'll take up more space. There's more of it. So moving on, what about density? Density is the ratio of mass to volume. We'll pause right here. You guys, I want you to do the first 2 bullet points again. As we were saying, the density is the ratio of mass to volume. So it's how much mass there is compared to how much volume there is. So ratios, I know you guys talked about those in algebra and geometry. So those are something that should be familiar to you. Now density is constant, that ratio for a substance, assuming you're in the same phase of matter. So if I have liquid water at the same conditions, no matter how much liquid water there is, it's going to have the same density, because density is how much compared to a volume it is. How much mass there is compared to how much volume. So, for instance, if I had something like styrofoam, and if I had styrofoam floats on water, right? Yeah. So if I had a really large piece of styrofoam, does it get more dense? No. It doesn't get more dense. You have the same density. So I can't keep on putting bigger pieces of styrofoam. It'll still float on water, because things that are less dense, they tend to float or tend to be buoyant. And that's what we talked about in Archimedes' principle. Okay? So that's why it's called intensive, because it's independent of how much is there. It's gonna remain the same. Make sense? Good. Moving forward. I love this question. Who should I pick on? Divine. Which one weighs more, 1 pound of lead or 1 pound of feathers? 1 pound of lead. How much does 1 pound of lead weigh? Oh, really? 1 pound. How much does 1 pound of feathers weigh? 1 pound. So what's true about their weight? They weigh the same, but I knew what you were getting at. They have the same. They have different density. So look at the amount of space 1 pound of feathers occupies versus 1 pound of lead. Connor, can you keep your head up? Thank you. So the same amount of mass is just in a much smaller volume for lead compared to feathers. You just don't, there's nothing to take down here, but think about that. You know, that's something that you see in your daily life. You know, you could have a pound of pillows, and it's going to be really hard to carry. It's big. You'll be all over the place and probably dropping them everywhere. But if you had a pound of lead, it's a little heavy, but you can just fit it in the palm of your hand. Right? Makes sense. Any questions before we move on? All right. So, we just talked about this. So, what we say is feathers are less dense because the same mass occupies more volume. Right? And we talked about Archimedes' principle and how that he was trying to determine if the crown was silver or gold. He found that the density of the crown that the goldsmith made for him wasn't the density of gold. So that's how Archimedes figured out that the king was cheated, which is bad. You know, yes, this is important. It'll help us understand. I'll pause it for a sec, and we can. So we really need to understand that to compare density, we're comparing two things: how much something weighs and how much space it occupies. So this is something you're going to want to write down. This is the formula for density. D is defined as density, M is defined as mass, and V is defined as volume. I picked those letters because, well, they begin with the same, that's the letter that the word begins with. And D is equal to mass divided by volume. So density is equal to the mass divided by the volume. Or you can say the ratio of mass to volume. What we say the ratio of and to is what's on top and below in the numerator and denominator, respectively. Okay? So moving forward, with a little algebra, I know you guys have taken algebra, we can get all of these formulas. And I'm going to show an interesting little graphic organizer method to help us remember that momentarily. Because you don't want to remember 3 formulas. All you want to do is remember one and be able to figure out the rest of them. Okay? So, moving on, we get to the triangle graphic organizer, which works for any direct ratio. Copy this down, copy this triangle, and I'll explain it momentarily. So in order to use this triangle as a tool, you want to cover up the variable that you want to solve for. For instance, say if you wanted to calculate for the density, you just get rid of this D up here, cover it up, and then the formula for D is equal to what? Mass divided by volume. Mass over volume. What if I wanted to calculate M? M is equal to density times volume. If it's on the same side, it's multiplying. If it's on top of one another, they're dividing. If I wanted to solve for volume, I cover up V, and my formula for volume is mass over density. Does that make sense? So we'll go through. I want to show you how I expect you guys to do this. This is just all the equations combined on one slide. So density is mass over volume, volume is mass over density, mass equals density times volume. You don't have to remember all 3 of these. All you have to do is remember one. You can figure out the rest, which is how to efficiently, learn things. So let's try a couple of these. Let's go in order. Let's go copy down one and then we'll solve for one. Then we'll go through the next two real quick, and we'll talk about these in just a second. Recording.